2, 4. Okay, so today we are having another automate the boring stuff session today. But before we go ahead and get started, I'd like to just share a little bit of information about Women Who Code for anyone who might be new joining us today. Our mission it's a global one, if you are not aware. We are helping inspire women to excel in technology careers. And so that might be coding, that might be managing, that might be as an analyst, whatever it is, however you'd like to do that, we are here to help. So we're trying to make sure that you gain the skills, the education to do that through a global community. So that is our goal, is to build that community and network here together today. For the record, we are inclusive, so please mind your manners. We are inclusive of all genders, gender identities, sexual orientation. It does not matter what your background is, political affiliation, whatsoever. Yes, we focus on Python, but we're not hating on any other languages here today. So please be sure to follow our code of conduct. And if you have any concerns about that or incidents, there is an address down here, or feel free to let us know, the leadership know in Slack. You can learn more about us, about leadership opportunities, scholarships, money at womenwhocode.com. And if you don't already know, there are other tracks available to us besides just Python. We are global online for Python, but if you're interested in front-end, block-end, chain, mobile, and cloud, I know that those groups are available as well. And I know that we have some great people in this group right now who are really into the data science one. So feel free to hit us up if you want information about those tracks. And a thank you always to our sponsors who make all of this possible. So we definitely appreciate Home Depot, Python Software Foundation, McKinsey and Company, and just Women Who Code's assistance today. And if you want to get more involved, you can go to this website to find out more information, or there's a leadership channel on Slack. We might even respond a little bit quicker over there. So we're looking for leads to help lead things within the group, or evangelists who are just telling the rest of the world how awesome we are. And feel free to talk to us at Women Who Code Python. Our handle is the same on all the awesome social media platforms. And if you are not already aware, we have a summit coming up, which is just a little one-day conference to celebrate all things Python. So please keep out on the lookout for that. We are requesting calls for proposals are out. So feel free to go to our website and find out more information of how you can get your talk slated. Okay. That's all of that. Let's go ahead into chapter 4. We started a little bit of it last week. We talked about lists, and now we're going to switch from lists into tuples this week. Does anyone have any questions about what I just said before we get started?
This is Lisa. Can you hear me?
I can hear you, Lisa. Hey.
The conference that's in Atlanta, is it going to be recorded?
Great question. Anyone else know? Because if not, we can ask.
Yeah, I'm not sure if it's going to be. We might not have the details yet, but we could ask.
Yeah. Yeah, and we'll definitely request, because I think that would be excellent information to share, and to maybe, look at the talks together and discuss them for the people who can't make it.
Oh, that's an awesome idea.
Yeah.
You can have like a little watch party or something. Okay. Cool.
Yeah, I just put a note here. We will ask about it, and we'll let you know.
Thank you so much, Liliana, for making that note. And thanks for the question, Lisa. Any other questions out there? Okie doke. Then I guess we're going to go ahead and jump in. We're going to spend, I'm not even going to put a time limit, or I'm not going to say a time because I lie every single time I do it. But we're going to spend the first part of this time finishing off the chapter. And then we're going to get into a little bit of code and actually see a program that someone has written. And if they had trouble, help them fix it. And if not, we can just review the code together. And also go over some practice questions. So let's go ahead and get started. Let's do a reminder of what we talked about last week. What are lists? Just in general. Open question. Do you remember what a list is? Well, my brain is possibly remembering that it's just a sequence of values in whatever order that we declare. So for example, we're coming back up here to the top. This is an example of a list. It is declared with brackets, and then it has the values on the inside delimited by commas. And one of the key things to remember about a list is that it can be changed, and so that it's considered so that you can just change any of these particular values. Does anyone remember how to change a value? Anybody out there want to share?
There's more than one way too, so there isn't just one specific right answer here. There's multiple ways to do this.
You can insert an object at a particular index into the list.
Perfect. So this would be an example of that.
To delete something from the list.
Yes, you can delete. So that would be the function called
DEL.
DEL.
Perfect.
That's perfect.
And I think I lost it somewhere in here. There we go.
So we can delete and we can insert. What about replacing? So if I want a cat to be something else in the one that's displaying, how would I do that?
You will just say the where it's located with the index, and then you will point it there. You'll assign it to change it.
Ah, there you go. Assign, like it.
Yes, assignment.
So if I come
in there.
One of these guys. Where's my assignment?
Oh, I think we're already past changing values in a list with index. There we go. Perfect.
There it is, that one with an index.
Okay. Are those all of the ways? Did we mention them all? Or at least the ones that we've learned?
You can append on to the end.
Ooh.
That's an excellent one. So you can, and there's different ways you can append onto the end. So
And you have the append and the insert, right?
well, so you have the plus, which is the concatenation, but you also have append, right?
Yes.
And that's specifically, let's see.
There, right there, you highlighted it. Yeah.
And it would automatically add it to the end. Cool.
And the insert, did we mention the insert too?
Lisa mentioned it at the top, but we can mention it
Okay.
again because that's really handy.
So this is where you're doing, you take the actual value dot insert, and then you say where you want to put it, at what index you want to put it, and then that value that you want to insert in there. So the difference between append and insert and the concatenation options is just, this is a method that you're using on the end of that variable. Cool. Well, I think that gives us a little bit of a, so I guess the reason I'm showing this is because these are ways that we're changing the lists. So that was a really key thing to remember. Wow, my computer's getting really hot and you might hear a fan in the background. That's a really key thing to remember, is that you can change the list. What we're going to be talking about here today are called tuples. They're very similar to lists, but they're not, because there are some key differences. And I believe we went through a little bit of this here right before we hit tuples last week. was talking about how strings are very similar to lists in that you can use indexing with them. So the same indexing that we were talking about for lists can happen here. We can refer to a portion of it, and we can even concat. Nope, I'm going to not end that sentence.
But there is a very, very, very important difference between lists and strings and tuples. And that is the schmancy SAT word warning here, the mutability, the mutation.
Mutability.
Yes. Mutability. So lists are mutable, meaning they are changeable, whereas tuples and strings are not by definition.
Gotcha.
So if you, whenever you, quote, change a string, you're getting back a copy of the original, or you have to make a copy of the original. You are not, you can't reach in and change a string once you've declared it. And that is the same for tuples, which screws me up sometimes.
And so that's what
Tuples look an awful lot like lists, but they're not.
So what you're describing is what we're seeing here. Here's an example of a string that's we're trying to change it, similar to the way we would change a list,
Right.
but that throws an error because a string cannot, you can't just go inside to the 7th position and change it.
Right. What you have to do is you would have to, you can reassign the label. You can reassign the variable name to a new string, but you cannot reach in and change Zophie the cat. You have to make a new one. Yeah.
Right. So this is an example of doing that. You're sort of slicing it, which is what we sort of learned last week. We refer to the first portion of it and then add that the, and then the last portion of it that we want to keep, and all of that is getting reassigned to a new variable.
Right. And you can assign it to the same variable name, but you're still getting a new string.
Agreed with that statement, yes. Good point, good point. Okay, so that's understanding strings and how strings are not mutable.
And yet strings, so what's interesting, remember way back in chapter 3 where we talked about being able to iterate over something and being able to perform operations on it. It's interesting because strings are not mutable, but they are iterable. You can go through the items in a string one by one, and you can refer to different positions in the string by index. And you can slice something. Remember, slicing is a backdoor way to copy, and so you can slice a string and effectively get back a reversed copy. And so I think this, for me at least, is a little bit confusing because it very much feels as if strings are mutable because they act very, very much like lists. And many of the same operations that you can do on a list work on a string. So anyway.
So it sounds like a lot of the things that you can do to a string that are similar to a list are really just display purposes only, referencing a portion of it, looking at what this little piece of it is, going through it, but never actually editing the contents of it.
Right, the string itself. And so everything that you do that would say, quote, return a new string, right, would be effectively a copy of your original, not your original itself. And I always have to remind myself of that because it feels functionally like if you go through and you say for letter in Zophie, print letter plus something, that feels like you're pulling Zophie apart, right? And reformatting it. But you're not. You're taking a copy of the value at the index in the string Zophie and doing something with the copy. You're not actually doing something with the string. So that's
So it's interesting. Well, I'm just going back to the fact that I'm glad we split this up. Is not only is this like a longer chapter, it's also just takes more mental capacity just to keep these little things straight. Okay, so that's sort of the concept of a string. And where am I going with that? The string and the fact that it is not mutable or cannot be changed.
Oh, so what is this? This is talking about memory management. If we scroll up just a little bit in this
Sure.
egg version here.
Oh, this is a list. Okay, that's why I got thrown off for a second. So this is showing how we can actually change a list specifically.
Well, this is, I think this is referring to, maybe I'm misreading these two paragraphs below, and I could be, but I think what he's trying to make a point of here is that in that code where you have eggs pointing at 1, 2, 3, the second line does not overwrite 1, 2, 3. It points the variable name to a brand new list.
Yes, that is a true statement.
And so
I guess that's what that picture is trying to show, is that instead of like taking an eraser to this 1, 2, 3 and changing it from a 1 to a 4 and the 2 to the 5 and the 3 to a 6, it just like totally replaced it. Took that one out, put something completely new in.
Right, and that 1, 2, 3 hangs around. This is probably way too much information, but that 1, 2, 3 is going to hang around until a separate process called the garbage collector comes along and says, is anybody using this 1, 2, 3? Oh, nobody's using this 1, 2, 3. Now I'll erase it.
Yes.
So it actually sits there, and there's this thing called a reference counter. And if the reference counter hits 0, then the cleanup process cleans it up. But it basically stays there until either the garbage collection happens or something else happens to either use it or erase it. So, yeah, this box metaphor confuses me a little bit, but.
Did someone have something else they wanted to say?
I was just saying that he does use the word overriding. He does say that it is overwritten. I mean, I guess it's semantics, but I guess the fine point is you would not be able to access the 1, 2, 3 again as that.
Right, unless you know the exact memory address of those values, or you referenced it in another way, effectively, practically, for all intents and purposes, it is gone from your universe. Technically, under the covers, though, it is not, I don't think it's overwriting. It's pointing the variable name to a new set of values, and the old set of values is cleaned up. And it's not necessarily instant, but for the use of your program, things that aren't referenced get garbage collected at some point. So,
and you know what we can do? We can even do a little, I'll make a parking lot item to go see like how a little bit more about memory management and how they sort of differ for those.
Right, and the timing. Yeah, get the details on that.
Yeah, sounds cool. Okay, so we're gonna push on down here a little bit. Does anyone want to review the boxes, or are we cool with getting into tuples?
Go to the tuples.
Yay! Okay, what's the first big thing you notice different about a tuple compared to a list?
The
parentheses? Yep. No longer, wait, no, they are parentheses.
Yeah, it has parentheses and the list has brackets.
Yeah.
And you also have different data types in a tuple, or you can have different data types in a tuple.
Oh, you can have different data types in a list.
But you can't have mixed data types in a list, right? Don't they all have to be the same data type in a list?
No, in a list you can have any data type you want, including objects, other lists, and lists of lists.
But can you mix data types in a list?
I'm sorry, what?
Can you mix data types in a list?
You can mix data types in a list. You cannot mix data types in an array. So that's the difference. In an array, which are not commonly used in core Python, they're much more commonly used in NumPy and like the scientific Python libraries. For arrays, all the data types must match. For a list, any data type can go in the list, including none type and empty and other lists and objects and all sorts of things. Yeah.
Okay, thank you.
Good question. And if
Yeah,
and
excellent.
for anybody else who might be new on the line, feel free to pipe in, stop us, ask questions. That's totally what this study group's about. So just wanted to encourage that. Whew. Okay, so even though we have parentheses on the outside, even though that we have, no problem, even though that we have parentheses on the outside of a tuple, you still are referencing it using the index nomenclature that we're used to. So you still do it with the little brackets. And you can still slice and dice them similarly.
Great. Very, very important difference, though, as you look down here, just like with a string, take a look at what happens when you try to change an item.
Tuple object does not support item assignment because they were trying to change that first position, index 1, 0, 1. They were trying to change that value to 99. And no can do, not allowed, because it is not changeable.
So we have a question in group chat. When would you use a tuple over a list, given that a list is more versatile? A list is more flexible, that is true. But one of the things that makes it flexible is also one of the things that may, in certain applications, make it slower because you are having to check what type something is. And also, if you are doing things like adding or subtracting, you have to go in and manage the memory of where you store things. And tuples can be more compact and faster because you know they're not mutable above a certain level. There is one corner exception that doesn't come up, but is a corner exception. But for the most part, tuples are not changeable, they're not mutable. So you know they're not going to be reordered on you. You know that they're not going to be changed. And you know that they are of a fixed length. And so knowing those things can help speed up code in certain circumstances or help you with the storage of information. One of the common tricks when you're doing like geographic information, if you're storing it, is to store the latitude and the longitude in a canonical order, like latitude first, longitude second in a tuple, so that the code that accesses it knows that, you know, position 1 is, or position 0 is one thing and position 2 is another, and that they won't change. And I've seen sometimes tuples can be used because they're not mutable, unless you put a list in them. You can use them as keys in dictionaries, and so I've seen that sort of thing happen as well, where you use like a latitude, longitude as a key in a dictionary for, say, a shop address at a certain latitude and longitude, something like that. So,
Cool.
yeah.
Thank you for the question. Okie doke.
So was anyone else thrown by the trailing comma? This still gets me. This still gets me after years of using Python, that when you only have one item in a tuple, you have to put a trailing comma.
It is super weird.
Okay, wait, what? Hold on.
If you only have one value in your tuple, you indicate it by placing a trailing comma after the value. Otherwise,
Yeah.
Python thinks you've typed it in a regular parentheses.
I don't like that. Okay.
Yeah.
Is that only with the tuple? Like you don't have to do that with the list?
You don't have to do that with a list because I think the square brackets are unambiguous in that circumstance. But for this one, because they've, of course, overloaded parentheses, which are used in function calls and Lord knows what, you have to put that trailing comma so that the interpreter knows that what you really meant was a tuple.
Yep.
So it screws me up from time to time.
Huh. I think I need to flag this and come back and remind myself of that. Interesting.
Yeah.
Okay. Okay, so converting types with the list and the tuple functions. So from what I understood about this, this is essentially, you start off with a list, and so you wanted to turn it into a tuple, or you have a tuple and you want to turn it into a list. And I guess in my opinion, please correct me if I'm wrong, that it helps with that concept of you want to treat it like something else because one is mutable, one is not. That might be one of the reasons why you want to do something like this. So here is an example of the list because you see the brackets being converted because we're putting it inside this function called tuple into a tuple. While you have a tuple inside of here being converted into a list right there.
And notice he's not saying it explicitly, but there is an unpacking operation going on here. So when you put a list inside the call to tuple, it's taking each item of the list and placing each item of the list inside a tuple. That's different from, say, enclosing the list inside parentheses and putting a comma after that. That would cause it to be a tuple, an item that's a list in it. So
which we'll see a little later. Okay.
Yeah, if you notice down here where it says list hello, that one word is not in a list. It went through each character of hello and put each character in the list, which is kind of interesting.
So it looks like we can convert, but okay, let me get this straight. So we can convert not only lists and tuples back and forth, but we can take a string and convert it into a list, or a string and convert it into a tuple.
Mm-hmm. You can, but you do have to be clear about your intent. Do you want the full string hello as one item in the list or in the tuple, or do you want a copy of each character in the string as its own item in the list or tuple? It looks as though, and we could try that if we wanted to really quick, it looks as though it will iterate through the string, and each character in the string is going to then become an item. I don't do this very often, so this is going to be a surprise for me. Okay, now instead, and now do tuple with hello and see what that does. Okay, now if you do list, hello comma, let's see if hello comma works. Nope, alliterates through. So if you want a list with hello as one item, looks like you need to put that in brackets and not call the constructor. So the constructor is designed to go through whatever it gives you item by item. It unpacks it.
Oh, just basically declare it directly. Okay.
Yeah, use the literal instead of the constructor.
The literal. I got to remember that word. Literal. Okay.
Use the round brackets.
Right.
Like, so if you wanted to do a tuple, you do the round parentheses with hello, but a comma. Remember, you have a comma after there. Yeah, there we go. Yeah. Whereas if you call the tuple constructor, it appears the default is that it goes through the iterable, right? Strings are iterable, so it goes through the iterable and makes a tuple out of the items it finds in the iterable.
Interesting. Yeah. Anybody have any questions or comments about the converting list to tuples? or vice versa? Okay, so now we get to talk about references. Let's see. Enter the following to the shell. Span equals 42, C equals 42, span is 100, C is 100. This is 42. Okay, so this is just referring to what's actually happening to the values that are being assigned to any particular variable, and then what happens to them later on when you copy them or reassign them other values. Interesting.
Yeah, when you reassign, right? So it's pointing. Yeah.
So lists are fun in that they don't do that exactly.
Yeah, there's one more layer of indirection, I think. This is where the boxes come into play, and my eyes start to cross. Yeah, this is a great example. This example here where you assign spam a list 1 through 5, and then you say cheese is equal to spam, and then you change cheese. But when you print spam, spam has changed as well. Does anyone know why this happens?
Okay, it's because you're not actually it's not that you're making a copy of that information. You're referring to the exact same position in memory.
Right, you just slapped another post-it on it. So when you say cheese equals spam, you are not copying the values in spam. You are giving a new name to the same values. So cheese is now pointing at spam, which is pointing at the data.
I love how you called it like you've slapped another post-it note. So like I'm imagining right above the 0, 1, 2, 3, 4, 5, a little post-it note that says spam and a little post-it note that says cheese. So no matter what, I'm still editing that same location. Could go by either name.
Yes, and that makes, I love that about Python because it makes it super flexible and easy. But if you don't remember that that is what is happening, then it is very common. I have done this more times than I can count, where I've done this thing where cheese equals spam, and then I go mutate cheese, and I'm sad because I've actually changed spam too. I'm like, what? Wait, why?
Okay, so that is the power of the copy that we're about to learn then.
Yes.
And that is why you want that. Okay.
And that is why I love slices, because slices implicitly copy. So yes, that is the power of the copy.
Before we hit into copy, I thought that's what we were going to get into just there, but now it looks like we're still talking about passing some references around.
Yes.
So let's see, we created a function called eggs that is going to append hello to the end of the variable that we pass in here. Oh, okay, so this is just passing the spam string along.
Yeah.
That's what we're seeing. So remembering that this function is going to be done, it's being defined here, but not called yet. So we come down here to the spam, and we have a set of integers being assigned, or a list being assigned to spam. And then on the next line, we call that function, passing in this list, and we find that that list now gets printed with 1, 2, 3, hello, what we appended on the end. And that's because the location of spam was what was passed up here. And so it's literally still editing that exact same spam list. It's not a copy of it that was passed, but the actual one.
Yeah. So languages tend to be divided, or were classically divided, into pass by reference, which is more on what we see here, versus pass by value, where it always passes a copy of your data. Python is actually not purportedly technically pass by reference, it's pass by object reference, but effectively, in 80% of the cases, it's the same behavior. Exactly what you said. What you are passing when you pass the variable spam to the function eggs is the references spam has to the data in memory. So you're passing the references in, and that's what's being acted upon eventually, right? The data that those references point to. And so then you get back hello appended to the end. Right. So it says they contain separate references, but they refer to the same list. Yeah.
Good to keep in mind.
You have to be careful in scenarios where you think if any other code might change the data. You have to ask yourself, am I okay? Is my code okay with data changing? If my code is not okay with data changing, then I have to protect it by making calling code or making functions act only on copies and not on, you know, the protected data. And so you have to do a little thinking and a little checking. It's not much, but yeah, you have to keep that in mind.
Okay, so here's where copy and deep copy come into play. Copy specifically, because copy is what's allowing us to actually, instead of passing that reference, actually make a copy of the values and then use those. But what looks like is important here is we have to have this copy, library available to us first before we...
Module?
Module, thank you.
You know, this may be, let's double check that. This may be a, although this book was updated for Python 3, I was going to say that might be a Python 2 thing because I didn't think I had to import copy, but let me see. Oh, no, you do. You do have to import it. Yeah.
So we got to import this module first in order to use this fun feature. That's sort of sad, but okay. It's not that big of a step. Okay.
If you're in a hurry, again, slicing where you just do brackets with a colon will give you a copy. So you don't have to import copy. You do have to import copy if you want to deep copy. But if all you need is a fresh copy of the data, then you can do a slice.
And you just slice basically from end to end.
Right. You do an end-to-end slice, which is basically calling copy.
Yeah.
Underneath the covers.
Yeah, it's the same thing.
Yeah.
It just, okay. I like it. But if for copy, if you did want to use that, you have that available to you here.
Yeah,
and
yeah.
So it's that same thing we were trying to do up above, it looks like. But this time we can actually change that little, that index without impacting spam.
Yeah.
Because we copied it first. We copied everything that was in spam and put it in cheese. Spiffy. And we got our boxes to help us do that. Wow. That was quick.
So the big difference, and people get very confused by copy versus deep copy. So the way I like to remember copy versus deep copy is, you know, you're allowed to put anything you want in a list, and you're allowed to put anything you want in a dictionary. And that includes an endless number of other nested lists and an endless number of other nested dictionaries. And of course, you don't want to go crazy with that. But if you're going to do that and then you call copy, copy only does one level. So if you really need a full and entire copy of something that is nested, then you need to call deep copy to make sure you've gotten everything. So that's, and that's not something that you should really be totally concerned about. Like I rarely had call to use deep copy on anything, but it is something to keep in mind that copy is not a magic kind of thing that will flatten everything out and copy everything. It only kind of goes one layer. So if I have a list that has other lists, that's okay. But if I have lists that have lists of lists, right, 3 levels, I have to deep copy if I really want to copy it. Good question. I will have to research whether or not this is in chat, whether or not slicing will copy everything. My first impulse is to say no, because I think slicing is calling copy underneath. But that's something we should parking lot. I'd like to know that as well. I'm not sure.
Okay, got it. Added to the parking lot. Okay, so I'm sorry. I started typing this because I just wanted to make sure I understood what you were saying regarding decopy. So
if you put a list around this, at least the way he's got it written in the book, if you copy this, I think you might still have a problem with the individual lists inside this list. And so if you want Python to unpack and copy those references as well, you need to call deep copy. But the way we can experiment with this is if you assign a variable to your nested list. Yeah. And then import copy. And then do testing 2 or some other word. Yeah, new test is equal to copy.copy testing. Yeah. And now edit, or change new testing at index 0 at index 1.
well, can we print it? I just want to see what's in it.
Sure.
Okay, so we got that. Okay, so now we're changing.
New testing at index 0 or at index 1.
Sorry, it's.
And then no, at the next, but not that index 1. Index 0 refers to the first list, but you want the first item in the first list. So 0 and then another brackets 0, yeah, or 1 equal anything you want to put in there, like new value. Pokemon. Okay, now print testing. See what happened? It didn't copy the references for the nested list. That's the difference between copy and deep copy. And I misspoke. It's not 3 levels. It's 1 level. It's anything nested. So if you really want, if you've got a nested data structure like this and you really want new testing to be its own copy, you have to deep copy.
So you have to do the decopy instead of the.
Yeah.
Okay, I didn't know that.
So do deep copy of testing. Okay, and now let's change Pokemon back to hello.
Perfect.
Yeah. So I would assume, and we could play with this with a slice, but I would assume that slicing is calling copy, and so slicing has the same problem that copy has. But we could test it really quick if you want to. So if you do like other testing, or some other. Is equal to, let's do new testing and a whole slice.
Wait a second.
You don't even have to do 0. Just do a colon.
That's right. And then just go to the end.
And then close the bracket. Yep. Okay.
Okay, hold on. I'm just in my head saying this to myself. So what we're doing is we're copying the entire list of new testing and assigning it to other testing, but we're acting like it's a slice. So that means it's copying it and putting it, gotcha.
Right, and the question that was asked is, does copy use deep copy or shallow copy? So now let's change something.
Use copy or shallow copy, or deep copy or shallow copy.
Yeah.
Okay.
So if we change something in other testing,
okay.
Oh yeah, I want cupcakes, please.
and then print new testing.
Don't make me hungry.
I'm sorry if I make an example.
Take a look.
What happened?
So there's your answer.
Change mode. Okay.
Slicing is a shallow copy.
So slicing is the same as copy.
It's just a copy, not a deep copy.
Not a deep copy.
Not a deep copy. Okay.
So don't
use it with multi-level.
right, or not in this scenario, not where you're going to end up mutating things because, yeah, whoopsie.
Cool. That was fun.
Awesome. That was an awesome practice. Something good to see.
One more question. Do you know if testing.copy and list testing are the same exact thing as copy.copy testing and testing? No, they wouldn't be, right? So testing.copy is going to copy the list, but calling the list constructor on testing. Let's see what testing, let's do that. So we've got testing. Let's call list on testing.
Okay, hold on. Let's see what testing looks like. Okay, so testing is just our Pokemon multi-layered list.
My guess is that the list constructor is going to unpack this and you will get one list, not a list of lists, but I'm not positive. That's a great question to ask. So let's call the list constructor. No, it's effectively the same. But it's not, but testing.copy is making a copy. List testing is taking the testing list and feeding it to the list constructor. If you're assigning a new variable, it might do that, where it is effectively making, you know what, I think you're right though. I think it is making a copy. So it probably, yeah. Right, but if you say testing 3 equals list.
Oh, yeah,
testing.
sorry. I knew I missed a step. Okay.
Yeah. Let's see if that's actually making a copy. Okay, now change an item in testing 3.
Stop looking at me.
No, this is really good.
Okay. I was trying to think of something else to eat.
Chocolate.
Tacos. Tacos. Now I'm hungry. Dang.
In a copy,
What does
right?
that tell us? The list constructor is not making a copy. The list constructor is merely running testing through the list constructor and returning it.
Wow.
Yeah, that's not awesome. That's a great, Kira, that was an excellent question, because at first guess I was like, maybe no, yes, no, but see, copy would have made at least a shallow copy of that. Now, it wouldn't have made a deep copy. No, you know what, that's interesting though. So maybe it made a shallow copy. So one way we could test whether or not it made a shallow copy is to replace the whole list in testing 3 with something else, right? So testing 3 at 0 is equal to like a brand new list, right? So make a new list of something. Cats, dogs, elephants. Yeah, colors. There we go. Okay, now print testing. Okay, so the list constructor makes a shallow copy, not a deep copy. So they are equivalent. List.copy, and the list constructor and copy.copy are equivalent. They're shallow copies.
I'm going to take a screenshot of this and study it. My brain is working better.
So can you go back to the, okay. So you change it for the whole one and you didn't change it.
Right. So the difference here is, right, a shallow copy copies one level of data structure, but not more than that. So when you have a list that is made up of other lists, a shallow copy will copy the outer list and the references to the outer list. But the inner list that points to data is not copied. And so if you go to the underlying data, right, in this case, the elements of the inner list, and change it, it changes for all shallow copies. However, if you make a shallow copy and you change the outer list's reference, which is what she did in this last step, then it's possible, right, to change the outer list's reference without changing its original list. It's the second level that is the problem here. So if you want everything, like everything in the hierarchy, then that's when you call deep copy. Does that make sense?
Yep.
I think I'm gonna have to play with that a little bit to see, but that was fun.
Yeah.
Great question, Kira.
Yeah.
Uh-oh. Every time I close it.
We have another question.
If you have a tuple inside a list, can I change the whole tuple to a new one?
Ooh.
Yes, you can. Can you change the things inside the tuple? No. But you can replace that entire tuple with a new tuple inside the list. But that's an interesting question, because if you do the opposite, so here is an interesting weird corner of Python. If you do the opposite, if you put a list inside a tuple, remember, tuples are immutable, except this thing about shallow copy, deep copy. If you put a list inside a tuple, you can change the item inside the list, thereby mutating the tuple. Don't do that. But you can, which is why there's this weird debate. If you want to go Google it, there's a whole Stack Overflow thread on it. You can use tuples as keys in dictionaries, except when you do something like put a list inside a tuple, because then it's not hashable. But that's a whole different thing. It's much better to just remember tuples are immutable, lists are mutable. Yes, a list can contain a tuple, and if you want to change that, you can change it because the outer data structure is mutable. So you can put a different tuple in there. And if you put a list inside a tuple, well, just don't. How about that? Oh, nice. Yes. Tupling. Yay. Camilla, you rock. Okay, so you can now take tupling at 0 and replace it with a new tuple. But you can't take tupling at 0, 0 and do it. Or you can give it a try.
Ooh. Can I change the whole tuple to a new one? Looks like it.
Yes, you can. But now try changing just step inside of tuple number 1 inside that list and see what happens.
Okay, so that would be tupling of 0 at 0 equals
Tuple object does not support item assignment. Python is watching and judging.
no dice.
No dice. Nope.
Cool. Okay. Summary. That was everything, or that was the rest of chapter 4 on tuples and lists, and remembering that lists are mutable, tuples are not, and that they store references to lists. Let's see, variables. They don't store the values directly, that they store the references to the list. And that copy and deep copy are our friends, unless we're trying to do some slicing. Slicing is a good option too. Okay. Any questions before we run into practice questions? There's plenty of stuff down here to try to remember. I think there are 2 ways to remove values from a list. Yeah, let's start here.
Yeah.
It'll remind us of some stuff from last week. What are 2 ways to remove values from a list? We talked about it a little bit at the beginning. Anybody?
Can access them by index.
Well, we want to remove the value. So if we access it by index.
Is that question 12?
I'm sorry. Let me highlight it. Question 11.
Oh, sorry.
Okay, I was like, what?
Sorry, I didn't clarify.
Okay, someone said it. I know it, but I don't want to say.
We review that.
Can't you pop off the end of a list? Oh, but does that remove it? Yeah. Pop or no?
Yeah, pop was one. I don't think it was in this chapter, but we did talk about it last week.
Yep.
Because I think, so pop is one. What's the one that's really like pop, but I think it's in the book? It's
Delete?
similar to pop.
Was it delete?
Del?
Delete? Or DEL?
Yeah, we have delete and we have the other way that is reference in the index.
Yep. So you have, oh, where did it go? So there's the delete function in action where you can actually delete that very specific portion of the index. Don't we have, is my brain not working here? I thought we had a remove as well.
Oh, remove, yeah.
So a remove is a little different because I think remove is where you actually remove a value. You don't need to know the exact location of it.
Yes, and if the value repeats, it removes the first one it finds.
Right.
So that's a slightly different behavior than a delete.
There we go.
You can also pop. Pop is when you want to be handed back the value in question. I don't think it goes over pop, but pop can sometimes be handy.
Now, does pop work in that, like, you can just use pop with an index, or do you use pop with a value?
If you don't put anything in pop, it takes the thing off the end. Let me pull up pop.
Let's do this.
Boy, I would so fail my pop quiz on methods. Index. It works on index. So give me the item at index number 1 and remove it from the list while you're at it. And if you don't specify an index, then it pulls off the end. So if you pop 1, then your list becomes apples and oranges, and bananas is handed back to you. So a good way to test this, we can add another thing onto the list, or you can just do it here. You can say my snack equal pop 1. Pop example at 1. Dot pop, yeah.
Well, actually, can we say, well, okay, nope, doesn't matter. So
Okay, now if you print my snack.
It has orange.
Yeah.
Woo. Cool.
Nice.
Yeah, so pop is nice, although there's a whole kind of school of thought with programmers where you kind of don't want to use pop because it does 2 very dangerous things at the same time, right? It hands you back the value and it mutates the list. And so you kind of want to think about the fact that it's doing that. And so there are programmers who would argue that it's just safer to ask for the value out of the list and not pop it, because then the list is unchanged, but you still get the value. So.
Okay, so if we were to name a few ways that list values are similar to string values, first thing I would say is that it's iterable. Does someone have anything else between list and string? What's similar about the two?
You can concatenate them.
Nice. I like that.
You can replicate both of them.
Yep.
You can sort both of them.
Ooh, yeah, sort.
Okay, sort, yeah.
Sort. Actually sorted, I think, and not sort, because you can't mutate a string. You have to copy it. So I think it's sorted, but yes, you can sort them. You can slice them. So
You can reference them by index.
ooh, nice. I like the reference by index. Yes.
And you can use in and not with it.
Oh, yeah, those
You
functions.
can use for loops with it too.
Ooh, you can call find on them too. That's true. Didn't think about those. Yeah.
The length function too, you can use for both.
Yeah,
That's
finding the
really
length of them. There's a lot of different things that are similar. What about different? What is the difference between the two, lists and tuples? Oh, sorry. Number 13. What is the difference between lists and tuples?
Well, lists are mutable, tuples are not. That's one.
Lists have parentheses. Wait, no, brackets.
Oh,
And the
lists-
tuples have parentheses. Sorry.
Yes.
Yep.
Mutable, no mutable, what else? Am I missing something else?
That's the really big one, I think, is mutable versus not, because, well, and so you can't call append on a tuple. You can't call extend on a tuple. You can't call insert on a tuple.
All because they're not mutable.
Yes.
Because they're not mutable.
Gotcha.
And you can't sort a tuple. But tuples can contain everything lists can contain, which is kind of interesting.
Oh, the next one is Jamila's favorite.
How do you type the tuple value that has the integer value 42 in it?
Come on, you remember that one.
Oh man, come
I
on.
like it, that one. I didn't like that.
Well, inside to outside. So let's write this out in the interpreter.
Okay, how do you, wait, hold on. Let me read this again. Let me make sure I get it straight. How do you type the tuple value that has just the integer value? Oh, that's why, yeah. Ugh.
So how do you make a tuple? How do you make a tuple that just has 42 in it?
Okay, equals
Tuple.
Tuple.
ah,
I know, that's totally, okay. And remember, yep, perfect. Okay.
Beautiful.
Integer 42,
oh,
not
yep,
string.
It's an integer, yeah.
yep. That's
Okay.
silly. Okay.
That comma is so silly. But I think I'm never gonna forget because it will remind me of you. So
Okay, so how do you get at something in the first position of a list, a tuple, or a string?
Use
What's
an
the index value of 42?
0.
Okay. And how do you type something? How do you use the function type?
you put type.
Mm-hmm. And we're looking for the type of the thing that's at what position in what?
So you want the type of the one that is called question, huh?
Mm-hmm.
Is that what you're asking?
I think so.
Yep.
And look at that, it's an int.
Yes.
Whereas if you take the index off of question 14, what do you get back? If you do type question 14.
Oh, I think I see where you're getting at now. Oh, I see.
Right. Yeah, I know.
Ah, ha, ha, ha.
I see.
Gotcha. Okay. Whew. Working that brain. Question 15.
I have a question.
Yep.
Can you guys hear me?
Yep.
Yeah.
Oh, okay, because sometimes I'm not sure if I'm being heard. So for that value 42, that's an integer, would you be able to use it in something as an integer, like add another integer to it? That question mark after it is just, not question mark, sorry. The
Comma.
after it is
Mhm.
just for,
So you're saying to add something in the end?
Oh.
No, I'm asking, we're saying that 42 is an integer, correct?
Mm-hmm.
So I should be able to add another integer to question 14 bracket 0, correct?
Yes, but you will not be able to assign it back to question 14. Do you know why?
Well, yeah, okay, I wasn't asking that. I guess I'm just trying to figure out, since 42 has that comma.
42 has that comma because the data structure is a tuple.
Oh, okay.
And
So,
remember, if we're declaring a singleton in a tuple, we have to use the
okay.
commas. Yeah.
Okay.
So
that's just for declaration. Okay, got it.
that's just for declaration. That's Python saying, I understand this is a tuple and not 42 in parentheses.
Okay, got it. Thank you.
Yeah. But that is very confusing because in the EU, if you're doing currency or even listing numbers, sometimes that comma can stand in for a decimal place. So yeah.
Okay, thank you for that.
Mm-hmm.
Any other questions? Okay, question 15. How can you get the tuple form of a list value?
Oh, I'm sorry. I call BS on that question.
Uh-oh.
I do.
How can you get a tuple form of a list value?
So to me, what this is asking is, I just assign it to well, I guess I have a list. I assign it to a tuple, and it becomes a tuple. That's what that sounded like to me. Is that not correct?
Well, how do you get the tuple form of a list value? How can you get the list form of a tuple value? I think the implication being a single value inside a tuple, not the whole tuple, but maybe that's not the case. Maybe this is a case of him asking about converting from one to another. I was just thinking of question 14 where he's, calling the type on the integer inside the tuple and thinking, why would I why would I go inside a tuple to take one value to turn it into a list? But
Oh, okay. Well, because I feel like I've seen the term list value refer to the whole list.
I see. Okay.
Like,
Yeah, I'm misreading. How does one do that? How do we do that?
With the tuple function and the list function's the correct word, right? Like,
yeah, function is the correct word. You can also use the term constructor, which is more of a like schmancy object-oriented programming word for it. But yeah, the list function or the tuple function.
so that's a tuple. And so you're saying do this. Oops. Right, Lisa? Is that what you're saying?
I think that was Dawn, but yes.
Oh, I'm sorry. I'm sorry, Dawn. I mixed up voices.
yes. Oh, wait, but if you want to turn that, oh, okay. Oh, right, list, yes, that is what I'm saying.
So you were starting off as a tuple and then
Right.
we're converting it to a list.
Yeah.
Coolios. I like it.
Every time I look at that, I get a little bit confused. Just because I'm used to seeing a bracket after list, but since we're calling the function, since we're calling the
Yeah,
list
I
function,
get confused too. I rarely call the list function, and so when I see it, it always doesn't look right to me.
Yeah, it's confusing. It's confusing to me too.
yeah.
My brain goes, hmm? What?
I'm like, what? Let me read it again.
Yeah.
Okay, question 16. Variables that contain list values do not actually contain lists directly. What do they contain instead?
References to the...
That would have been what I said.
That's perfect. Yeah, that's it. References.
Okay, question 17. What is
Oh God.
difference between copy and deep copy?
All right. Bethany's just gonna put herself on mute.
Who'd like to take it? Anybody?
Come on, we need someone else. No one?
So I'm thinking,
Copy.copy is a shallow copy?
right. What does a shallow copy?
I knew you were going to ask me that.
Shallow copy. I like it.
Oh, I guess it's a shallow copy is, it's like a reference copy. It's not, I don't know, I can't spit this out.
No worries. So if we come back, oh, sorry. Let me pull up.
Yeah, pull up this. Yes, this needs to go in our repo. We can go back and comment this.
Those are good examples, yeah.
Okay, so I'm gonna just take this piece and then like try this again. So if we have, whoops.
Space.
This is question 17. Okay. So here's our question set. We got a list here. And you notice you have, I'm sorry, someone's gonna say something?
No, please go.
So we have a list of lists. So we have one big list on the outside, and inside of that, in index 0, we have another list. And in index 1, we have another list. So A shallow copy, my understanding of a shallow copy, is copying the fact that there is a list here. But a deep copy is if we're trying to copy these individual, like the individual pieces of the inner list. Is that sort of correct-ish?
That's a great, yes, that was a great explanation. Shallow does the outermost. Deep does whatever it finds. So if we had 3 levels, one big list, 2 sublists, and inside each sublist there were more lists, a deep copy would copy all 3 levels. A shallow copy only copies the outermost.
So really it's only applicable for when you have lists within lists, or this nesting concept.
The nesting concept in general.
Yeah.
Yeah.
If you don't have a nesting concept, just work with copy.
Right. Work with copy, work with slice, work with whatever feels best to you for making a general purpose copy. But when it comes to anything, and that is one of the great things about Python, but one of the gotchas is lists, tuples, sets, and dictionaries are data structures that can contain an endless amount of other data structures, right? So a dictionary can have lists and sets and all sorts of things shoved in it. So can a list. And when you have that sort of situation, that's when you have to start paying attention to deep copying as opposed to shallow copying. When you shove things in, shove data structures inside one another, basically.
So what would a shallow copy of Q17 return? Only the second list?
Well, let's demonstrate it right here.
Wait, hold on. How do I do this?
Copy.copy. Perfect. Yeah. And that looks fine, but here's where the problem comes. Now, let's change by in second question to adios or something else, some other. Some other phrase. Yeah, nice. We've changed it here, but
Okay.
we also changed it in Q17 because what we copied was the outer list and its references and not the inner list's references.
Okay.
So if we now replace all of second question at index 0, so we replace the whole list, you can do that without changing Q17. But if you go inside the whole list to the individual element inside the list and replace it, you replace it for both second question and Q17. Because as it turns out, they're both pointing to the same data. Do Vidania. Aloha, yes, nice.
I was running out of them. Okay.
Okay. I see.
So deep copy copied the whole tree. Shallow copy only copied the outer list. So now if we went into second question and we replace second question at index 0 with an empty list.
Wait, just there?
Yep, with an empty list. Now if you print second question,
Ooh.
and then you print Q17,
huh.
Okay, because it copied the outermost references. It just didn't copy the innermost references, right? So
That's why we can't, okay. Can't change it. Whoa, that's deep. Deep copy is deep, man.
deep copy is deep, man. And it also effectively, unless you're working habitually with this sort of nested data structure, deep copy just, you don't have to use it. You don't have to use it very often. Copy is very useful, and remembering that underlying data can be mutated is useful. But I've only seen deep copy in situations where the whole application is about nesting data structures, like lists of lists, right? Nesting things inside of each other. That being said, here we go. Speaking of nested things.
Yep.
This
The only way this is gonna work.
Yeah.
So we're gonna go to the code, I guess. We're gonna use this last about 25 minutes to go over this little piece of code that we need in order to make this image on the screen. So what we were asked to do was basically create a list of lists. So if you see, grid is a list, but inside of that list, it has another list and another list. So at index 0, there's this list of periods. At index 1, there is this list of periods with 2 zeros in the middle, and then so on and so forth. So we were supposed to create this list first, and then using that, make it print this. And so it sort of gave you some hints on how to do that. So if you notice, this list is actually, if you treat this top section at the 0, 0 coordinates, notice that this very first row that it prints here is this first column that you see here. And this second row that you see here is this second column of indices going down all of these lists. So you're essentially printing the first, the 0 index of all the lists, the first index of all of the lists, the second index of all the lists, over and over and over until you get to the very last one. So in order to do this, we did have to use a little bit of a matrix fun going on. Did anyone want to share their code to show how they did it? Or
I can show mine, but I think I would prefer someone who did I did not use the grid at 8 at 0 methodology for either of my solutions. So if someone did that, I prefer we walk through that first, rather than what I did.
Now you're making me wonder if I did it right. All right.
Oh, no. I think you totally did it right. I'm just saying that I used 2 different methods that are different from going through and listing the coordinates one by one. And so I prefer we walk through the thought process of doing the coordinates one by one before we look at my alternatives, because I did 2 alternate methods. So
I have a version to show. Would anyone else like to show their version? Or if you, okay.
right.
Then let's see if I can remember what I did here. I had to write this down here at the bottom to remind myself what I was trying to do.
Do you want to put it into Python Tutor to walk through, or?
Ooh, fancy.
I've gotten addicted to walking through code that way. I'm sorry. You don't have to if you don't want to.
Do. Okay, so we have printing the first list, first item, second list, second item. Okay, so in order for me to like wrap my head around this, I had to, once I had actually written out this grid, I actually had to remind myself like what it's printing. And so I'm trying to get this very, very first item in each list, then the next item, then the next item. But I had to remember this concept. And that's why I had to write it down here for myself. It's like you're going to go to the first list and the first item in that list. But then for the next one, in order to move down, I have to go to the second list, but the first item in that. So what you'll notice is like is this consistent pattern of you're iterating from list to list to list. So first list, second list, third list, fourth list, but it's always the first item, the first item, the first item. That's how I get all the way through the first one. Then the second one, it's still I still go first list, second list, third list, but now I'm just working with the second item and then the third item. So that's, I guess, just sort of how I have to remind myself. That's what we're printing each time.
That's a really great way to think about it, though. Yeah, that's good.
Okay, so I wrote this last week, so let's see if we can try to figure out what's going on here. And actually, let's just visualize execution and hope it works. Next step, I guess. So it's going through, declaring, I guess, this list, defining it all. Whoa, there's a lot of it.
There's a lot going on there. But look at it. It knows. Look.
Okay, so so if I'm saying this right, this is the master list of grid.
Yeah.
And at that very first 0 index, look at that, it's got another little baby list. And in that list, it has a little period that we see there. Cool, and it has all the periods for that whole list. Okay, I get it.
Yep.
Okay, so what I decided to do, I did for loops just because that's what I remember about a matrix. Whenever it's like a matrix, I'm like, that means you have to nest 2 for loops together because of reasons. So,
well, not of reasons.
No,
That's exactly right. You loop through all the items in the outer list, but since it's a list of lists, then for every item, you have another loop for the items inside, right?
Right.
Yeah.
Yes. So let's see. And I'm sorry, I used I's and J's. So I used these I's and J's before you like went off on a tangent last week about saying how I's and J's are not cool. So sorry about that.
You know what though? So I and J is very, very commonly used in billions of examples, especially when you're dealing with data and data science. It's just something that's kind of in the nomenclature. So, of course, it's natural to use them. I prefer not to because my brain is small and I confuse easily, and so words are better for me. But yeah.
So maybe what I should have written here was for outer list, in the range of the length of this very first list.
Yeah.
For that, we're gonna basically the length of it for everything in this list, we're about to loop through it one by one. So I put this first part to say, okay, we're going to stop looping as soon as you notice that you have reached the length of this list. But as long as we have not met that criteria, let's go on inside to the new break into that very first list and start printing stuff off. So that's what my J is for. It's for like that inner list where the good stuff is. We're going to start doing some stuff. So I guess I should sort of step through, sorry. So we are not at the length yet. So inside of this little baby list, and once again, we're not going to break out of the little baby list until you've maxed out the length of it. We're going to print that particular, like this unique item, that index very specifically. So let's see what happens. Where's J? So I is 0 and J is 0.
So you got a little period because the 0th list in the 0th position in the 0th list is a dot. And you can see that on the tree over here to the right, because if you scroll all the way down, which is a little hard to read, but you see position 0, and then you go all the way up to where that's pointing to, it's a list, and then position 0 in that list is a dot.
I don't know if that's too small, but hopefully you can see everything now. Oh, okay, so I didn't mention this. I had to add this at the end of it because when you do a print, it will automatically include a new line. So what this is saying is at the end of it, instead of doing a new line, just end with an empty string. I believe that's what it's saying. So that's why it's still staying on the same line and not printing period, enter, 0, enter. I'm trying to remember why I flipped the J and the I. There was an important reason there.
Grid at J at I. Oh, because I refers to the row and J refers to the column, and you need everything at position J all at once and then the next position J, right? Because we're inverting rows and columns. That's why you had to do that.
Okay, I see, yeah.
Everything at position 0, at position J, for every item in I. Right? So you start with 0 for every row, then you move to 1 for every row, then you move to 2 for every row. Yeah.
Okay, that's what's going on there. And if someone has the book open, make sure this is printing right, because I'm just printing right now. I hope it's printing the way it looks like in the book.
It's so far so good. I think the book might have had spaces between, but it doesn't have to. No, the book doesn't have spaces between. I put spaces between mine because I like the spacing better.
You know what just occurred to me? Is this a heart?
Yeah.
Oh my gosh, I did not know what it was. I'm like, okay, this is like a series of zeros. Okay, if that's what it is. Oh my gosh.
How do I unpack this?
Yes.
Yeah, I heart Python. Yay!
Jeez. Okay. Oh, oops. Can I go back?
Yeah.
That's awesome. You can go back. Okay, so we're ending towards the end. So we're at list 5, 1, 2, 0, 1, 2, 3, 4, 5. And we are in position 8, 0, wait.
Yeah.
0, 1, 2, 3, 4, 5. No.
No.
No, no,
Yeah,
no. Other way. Other way.
Yeah.
Yeah, that's right. They're backwards. They're
They're
backwards.
backwards.
Ah!
God,
Okay.
you and I both. Wow. Like, whoa, wait a minute. Where are we? Where are we? Yeah. So we're at row 8 because J is 8, and we're at I5, which is the position.
J
Right?
is so 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're here and we're in position 5 of that list. 0, 1, 0, 1, 2, 3, 4. Okay, so we've just placed in that 5, and so it's about to print that very last 0 there. And now it goes back to the top, and the length of this
Is now equal.
it's now equal to the length because we're all the way down and all the way to the right. So now it's going to print nothing. Why did I put an extra print there?
Not sure.
I don't need that.
No. No, you don't.
Okay. But anyway, pulls it back up to the top, and it's going to do that very last verification here too. And it's done. Huh.
So I would suggest, I'm not sure, but I think if you remove lines 12 and 13 and also 15 and 16, you are still going to be okay because the for loop doesn't, you're saying that you are going to be iterating through the length of the grid. So you can do the length of the grid minus 1, and then you don't need to put in the length check, right?
Length of the
So because it's going to, right, range of the length of the grid, right? So the length of the grid, no, you don't even need to do a minus 1 actually, because range is exclusive of the final number. Yeah. So it should loop, and then you can also eliminate the print on line 18.
Oh yeah. Oh yeah, duh, because so yeah, I see. Uh-oh, what did I just do? Jamila.
I think you clicked, yeah, you clicked over one tab. If you click, there's your tab right there. Yeah.
Okay. So yeah, this is just repeating what a for does to begin with. Come on now. Okay.
Well, but it's hard, right? Because you would need that if you did a while loop, right? While J is under the length of. But for the for loop, because it's an explicit number of steps, you shouldn't need that. So let's just double check though. And if you click all the way to the end, like the last, there's a last fast forward button.
Oh,
You know what though? We've got a problem. Maybe that's what that print is you needed a return.
I needed a return at the end of the, that's what I was doing.
That's what that was for. See, you're smarter than the both of us.
At some point I thought of something. Okay.
There we go, yeah. Yep, voila.
Okay, so I can clean that up pretty nice then. Make it more compact. Probably save on something. Okay. And next time I will make sure to comment. That way I remember what I was doing. Because I didn't do that on top of this stuff. But did anyone have any questions?
Can you hear me?
Hey, what's up?
Yeah. Are you going to put this recording, a link to this recording in the Slack? Because this was a lot of good information.
I know, wasn't it? Yes.
Yeah.
As soon as I figure out how to do it, I'm going to do that. I'd like to say I'm going to do it tomorrow, if that's okay. Because I finally have time, so I will do that tomorrow.
Great. And what's our assignment going to be? Are we just going to do half of chapter 5 next time, or what?
Ooh, let's go check.
Yeah, let's look at chapter.
Does anyone have any more questions about chapter 4 before we talk about next week?
No, does anyone have any other code solutions to the character grid to
Yes.
share?
Maybe if you did it differently than me, more efficient. Or less efficient, or if you want us to just take a look at it.
Yeah. I have a couple other solutions I can show, but I'm curious about your guys' solutions. So, ooh, dictionaries. Oh,
I
that's
wasn't
what
able to
5
do
is.
that problem. It was tough.
It is, these sorts of problems always murder my brain because, yeah, they always murder my brain.
We might need two sessions for these too.
For chapter 5?
Yeah.
Yeah, that's very important to learn well. So.
Yeah, dictionaries are not a thing that I am overly familiar with.
I think you will love them once you get to know them. But I would agree that, we get to the tic-tac-toe. I can trot out my buggy tic-tac-toe program. I actually made
Nice.
this tic-tac-toe program, both on the command line and I threw it in the journal. Yeah, wow, he really gets into it. That is a lot. That is a lot. And then he goes nested. I would say we maybe only go through to where nested starts, because if you look at like up to nested, that is a lot. A lot of stuff.
So
You're right.
So let's see. Oh, here? Stopping here, nested dictionaries and lists, get this far?
Yeah, because if you look here, I mean, he's already going over like keeping tic-tac-toe moves in a dictionary and building a tic-tac-toe board. And
do we need to stop a little earlier just so that we can wrap our heads around what we learned first before we go into this, or do you think this will be?
Well, what does everyone think?
I think we should stop a little earlier.
Earlier? Yeah.
Yeah.
What do you have before that nested?
We have pretty printing. The set default method. I'm sorry, I didn't read ahead, so I'm not overly sure what
I think until that nested will be okay though, but.
Well, I just think I don't want to overburden someone with going through his code and his program though. I think Jamila has a good point that maybe we focus on the things that dictionaries individually do as a data structure, and maybe not the application of using one in a program until we all feel real comfortable with manipulating the data inside a dictionary and what it does.
Well, that might be a good idea because, like, we had a really healthy conversation today about tuples and lists, and we did last week too, right? Just, we can probably keep ourselves entertained with questions. I was like, I wonder if it does this. I wonder if it does that.
Yeah.
We can just spend the time playing with it and then feeling more comfortable with it. And then if we run out of time, we can come up with little just problems for ourselves. That way we're really comfortable to dig into the code the following week.
So we're like a good strategy to me. After using data structures to model real world things right before the tic-tac-toe, or?
Yeah.
Like we stop, this is, don't touch this.
Yeah.
Okay.
We stop right before that.
Okay. I think that would be good, especially since there are there's some good examples that I've seen out in the wild of using dictionaries in addition to the ones he has that we can we can discuss. But yeah, this is a lot. The dictionaries are really cool, and I really love dictionaries, but it takes a little to get used to them at first because you can stuff so much stuff inside a dictionary. So, yeah.
Okay, so to recap, we're going to do chapter 5, but we're only going to get all the way to this. We're going to do pretty printing. Pretty printing. So that's the last thing you're going to try to do. And then we're going to hard stop, not going past this marker. We're just going to do pretty printing. And then we'll keep ourselves, ask questions, have a lot of fun next week. And then we'll tackle the next part in the next conversation. Sound good?
See.
Yes, that sounds good.
Woohoo! And so I have a couple follow-ups. We're gonna ask about the recording for the summit. We're gonna get you some information on that. We're gonna talk about overriding memory in Python. And throw that in the Slack, just about like what memory is and how to override it or not override it. Let's see. And we had some really good questions today that was brought up during the chats. And so I think I might like just copy those questions out, put the answers that we discussed during this session in the Slack, just as a reminder to other people who might not have made it, or a reminder to ourselves. Also, I'll post the notes for this last bit, because if you'll notice, the chapter 4 notes are missing the tuple section. So I'll get those posted as well. And we will get you a recording for this. So this whole recording that we just had, as well as the previous ones from the previous chapters, those are coming. Any outstanding questions or anything?
You're doing a great job.
Oh, we all are. This is awesome. As everyone feels like we're learning, right?
Yeah, you're doing a great job.
Cool. Thank you so much, Bethany, for keeping us on track, answering all the hard questions. Definitely appreciate it. Okay, cool. Well, then I think I'm ready to go. Anybody else ready?
Yep.
Okay, have a wonderful, oh wait, one more suggestion. Can we get more problem sets somewhere that we can practice and discuss? Great suggestion, we can work on that for sure. And is everyone on the West Coast? I don't think so. I think we have people from a couple of different time zones here. I know we have Central Time and we have Pacific Coast. Anybody else? So we at least have 2 time zones working. Ooh, East Coast, yay, 3. Okay, so then it's very late for you. We'll let you go. Thank you guys, everybody, so much for coming, and I'll see you next week. Bye.
Bye.